So hi class, today I will be discussing or presenting examples on mirrors. So for the first one, a concave mirror forms an image on a wall 3 meters in front of the mirror of a headlamp filament 10 centimeter in front of the mirror. For A, what are the radius of curvature and focal length of the mirror? For B, what is the lateral magnification? And what is the image height if the object is 5 millimeters? Now, you can see here a diagram where we visualize or illustrate this problem. So this is the mirror or the concave mirror, this one. And then this is our object. It is 5 millimeter. This is the center of curvature. And then we are going to look for the height of the image. Now the distance of this object from the mirror is 10 centimeter. And we are going to look for the radius of curvature or big letter R. And then the distance of the image is 3 meters. This is S prime. This is your image. So here the variables that were or that have this prime here or the apostrophe indicates the image properties. I will write the given. We have the S prime. This is for the image. Okay, the distance of the image from the mirror, that is 3.00 meters. The distance of the object from the mirror, that is 10 centimeter. Okay, so note that they have different units. Okay, and then for the given for B, we have here the height equivalent to 5.00 millimeters. So note that we have different units. So I will stick on centimeters. So I will convert this to centimeter. This is 300 centimeter. For the 5 millimeters, this is 0.5 cm. Okay, now to answer this problem for letter A, we are looking for the radius of curvature and our focal length. And we are going to use our formula, that is 1 over S plus 1 over S prime is equal to 2R, in order for us to calculate for the radius of curvature. Okay. Now, plugging in the values, 1 over S, that's 1 over 10 cm plus 1 over S prime, that's 1 over 300 cm equal to 2R. Note that they have to have similar units. Okay, before solving or before calculating, you must convert the other um, or if they have different units in the given, so you have to convert it in order for them to have similar units. Okay, now this will give us 0.1033 equal to 2R. So to solve for R, we will be doing a cross multiplication here, or in order for us to transpose R to the other side or to the left hand side. So this will become R equal to 2 over 0.1033. Now, solving this will give us 19.36 centimeters. So this is now our radius of curvature. Now, what about our focal length? Note that our focal length is just half of our radius of curvature. So R over 2, or 19.36 cm divided by 2, this will give us 9.68 cm. So this is now our focal length of the mirror. For letter B, we are going to look for the image height and the lateral magnification. Now, the equation or the formula for lateral magnification is equivalent to M negative S prime over S. Okay, so we will substitute our given, that's negative 300 cm divided by 10 cm. Okay, So this will give us negative 30.0 or 30. So maka-cancel out sa unit. Take note that our lateral magnification is unitless, and then the negative here indicates that our image is inverted. Also, this 30 means that our object is 30 times bigger than its original size or original height. So here you can see that this object here will be 10 times bigger on its image from the mirror, or its reflection from the concave mirror. Now, to solve for the image height, given that the object is 5 millimeter or 0.5 cm, to solve for the image height, I'm sorry, we will multiply 30, okay, by 0.5. So this will give us 15 centimeters. Or so that is the answer for this problem. For the second example, we have Santa checks himself for a suit using his reflection in a silver Christmas tree ornament 0.75 or 0.750 meters away. The diameter of the ornament is 7.2 centimeter. Standard reference texts state that he is a right jolly old elf. So we estimated his height to be 1.6 meters. Where and how tall is the image of Santa formed by the ornament? Is it erect or inverted? So here you can see an image, okay, the figure where it illustrates our problem. Now, what we are going to look for is the distance of Santa, or the distance that the image of Santa was formed by the ornament, and its height, also the image height, and we are going to determine if it is erect or inverted. So to solve this problem, we will write first our given. We have is the object height, 1.6 meters. And I will convert it to centimeter, okay, in order for us to be consistent. You can still use meter, but I will just use centimeter. And then the object distance is 0.750 meter, or this is 75 cm. And we also have the diameter of the ornament, that is 7.2 centimeter. It is negative since we are using a convex mirror. Note that for convex mirror, we have negative radius and focal length. So our diameter will also be negative. This is for convex. Okay. Now dividing this in two, since our radius is half of our diameter, our radius now is negative 3.6 centimeter. So this is our radius. Now, so we need the radius in order for us to calculate our image height, or we need our focal length also in order for us to solve for our image height. So in this case, we will use the focal length. You can still use this, okay, using the equation 1 over s plus 1 over s prime equal to 2r, or you can use 1 over s plus 1 over s prime 1 over focal length. So here I will try to use focal length. No? So we will divide this by 2, which will give us negative 1.8 cm. So you can still use this one by using the given in our radius, but in this case, I will just use this equation for you to know that it is also possible to calculate for the objects or the image height using this equation. Now, in this problem, what we are going to look for is our image distance, and also our image height. So that's y prime. So to look first for the image distance, we are going to use our formula over 1f. So I will transpose this variable to the right hand side. So this will be 1f minus 1 over s. Okay, so this will become minus since it is positive here. So kapag ililipat natin siya sa kabilang side, magiging negative na siya. So I will substitute now the values. This is 1 over negative 1.80 minus 1 over 75 cm. So this is both in centimeter. So calculating this, you will obtain negative 0.5688. Okay. So this is now our, this is not yet our image distance, but the 1 over s prime. So this is negative 0.5688. So to solve our s prime, we have to get the reciprocal of this one. So that's 1 divided by negative 0.588, which will give us 1.76 cm. Now this is now the distance of our image or Santa's image from the ornament. Now what about Santa's height? So to get the height of Santa or the image of Santa from that was formed in the ornament, we will use our lateral magnification formula, that is negative s prime over s. So this will be negative 1.76 cm divided by 75 centimeter. So this will give us 0.0234. Okay. Now note that our this should be negative. No. So the negative here indicates that our image is inverted. So to look for the height of Santa, so for the height, our height is actually equivalent to this formula. Lateral magnification is equal to y prime over y. So to solve for y prime, we will multiply both sides by y, okay, to cancel y here. So this will give us y prime equal to y times m. So the original height or the object's height is 160 centimeters. Okay, so we will multiply it by 0.0234. So this will give us 3.8 cm. Now this is the height of the image. Okay, that Santa's image that was formed in the ornament. Okay, so we were done, okay, or we have answered the object, or I'm sorry, we already answered the image distance and the image height. Okay, we were also able to indicate, or we were also able to determine that the image is inverted because of our negative lateral magnification, okay, because of the negative here. Now for the third example, we have here, if you look straight down into a swimming pool where it is 2.0 meters deep, how deep does it appear to be? So you can see here an image, okay, of the problem where they indicated our NB as the air and our NA as the water. Okay, so these have different way or process in solving compared to our two previous examples. So this involves refraction. So we have a different formula for this one in order for us to solve for our image height. So we are going to use this formula. So you are going to use this formula if there are two mediums. Okay. So in this case, we have the air and the water. Now I will be substituting the values here, so we have 1.33 over 2.00 meters plus 1 over s prime equal to 0. So I will transpose 1.00 over s prime to this side, so it will become negative. So what will be left to the left hand side is 1.33 over 2.0 meter equal to negative 1.00 over s prime. So calculating this in your calculator, you will get 0.665 over m. So I will retain m here since it is a unit, because our index of refraction is unitless, but our s, or our distance, is have a unit. So I will retain the m here, but as a unit, and then this is s prime. I will transpose s to the other side. So I will be multiplying both sides by s prime. So this will cancel out here. Okay, we will have now s prime times 0.665 meter equal to negative 1.00. I will be dividing both sides, or I will be multiplying both sides by m, 0.665, and then here m over 0.665 for this to cancel out, and then we will be left with s prime on this side. What we have now on the right hand side is negative 1 over 0.665, and then our unit is in meters. So if you calculate this, you will get, or you will obtain, negative 1.50 meters. Now note that the negative here indicates that the image is virtual. Okay. So this is different from the lateral magnification. If we have m as negative, it indicates that the image is inverted. But in this case, the distance of our image is negative, so our image is virtual. Our s prime here is negative 1.50 meters.